So, data is the new oil. That's a quote you probably heard already 1,000 of times, but storing and hoarding data into silos often reduces its usefulness and really doesn't bring much added value. So once processed, data often brings further insights and brings up more use cases. And that's basically what we're going to talk about today. So thanks for the introduction, Sakari, but my name is Glenn. I'm Azure IT domain lead at Codit. I'm Microsoft Azure MVP. For people who have questions during the session, don't hesitate to raise your hand. Afterwards, you can contact me through one of these channels. I'll be happy to answer and to talk to you. So for people who are not familiar with Codit, we were founded in 2000. And then basically spread across the entire Europe. And we have been focusing first on integration, doing BizTalk and stuff like that. But then we basically outgrew that, and we're now doing API management, IoT, and Azure solution. But most of our business is still in the integration space, doing the BizTalk. So today I'm going to guide you through the process we've been involved with to build a data sharing platform for the Port of Antwerp. And it's really important to see that data and big data in general is the fuel of the economy of the future. So data is and will become more and more important in these days. So I will guide you through some concepts, some lessons learned, some pitfalls we've seen during this hour. As already said, don't hesitate to ask questions. So a bit on the agenda, I will first set the scene, explain you what Nextport is, what we've done over there, how their architecture works, how the entire platform comes together, a bit general concept of data. Then we'll talk about data ingestion. So data ingestion will be about data that is entering the platform and entering a data sharing platform in general. Then we'll talk about data sharing, notification, and of course, last but not least, the most important thing is the API economy we currently live in and the APIs that are there to enable access of the data to the outside. So Nextport was founded in 2016 to answer the Port of Antwerp's call for more open and shared data. So Nextport answered that call and was founded. And Nextport aims to gather all the data from the different company and especially all the data across the entire logistic chain and gather them, enrich it with metadata, and then make it shareable throughout the community. And it really aims, Nextport aims to be a benefit for the entire community, the Port of Antwerp, to be more flexible, to be more, to really have more insight in their data and in the entire logistic chain. So the vision, and I'm talking about Nextport here, but this vision can basically fit a lot of data platforms or data sharing ideas. So first of all, you have your data. So a data platform needs to be capable to handle all types of data. Is it transactional data? It needs to handle streaming data, master and reference data, and of course, as nobody else mentioned it before, blockchain. So you can cross that off your buzzword bingo list. And then, of course, there's AI. So Nextport aims to build AI on top of all the data it's gathering and sharing, and to really start learning from that data and to see how that data can evolve and bring in more lessons from that data. So I will come back on that later. So that's one side of the spectrum that mostly focusing on data, gathering data, getting insights of data. And then you have the other side where people are consuming the data of the Nextport platform or your data platform, and they're building different types of applications. So that can be web applications, mobile applications, entire enterprise system can hook up on the data to get more data or to enrich their data they have, and to really enrich their enterprise system with data from other companies and from the community. And then, as already said, Nextport is aiming to really have that collaboration going and to really make the Port of Antwerp a better community base, so that not every company is working on its own island, but really sharing their data across the port. So the building blocks of the Nextport platform are, of course, we've built this, and the platform is built entirely on Azure. So a big important layer is the API management layer, as this is really the main entry point of the system. All APIs are behind that. Even the data that is being ingested through certain channels will come through that API management layer. And then underneath you have a whole services layer who does, of course, your sync and async processing. You have some workflowing going on, events and commands for decoupled routing. And underneath you have your whole layer of enabling technologies. And then on top of that, again, on top of that data, on top of that platform, you have a marketplace. I will show it you later. And the marketplace of Nextport is where you can subscribe to certain APIs or to certain data feeds, and you can start consuming that data feeds on your own. There's a whole data sharing engine where data suppliers can do checkboxes, see who can access their data, or even set the data open for the entire community and others. So that's the interface layer, and then you have your users and supplier who will start to consume your data, building their own apps, portals, and so on. And then, of course, you have your whole governance and operations layer, who is handled by Nextport itself, who is managing that entire infrastructure and doing operations and support on it. So the data flow, that's an important aspect of a data platform and a Nextport in general. So first of all, we have our data suppliers. Data suppliers are people who are ingesting or bringing their data into the platform. As already said, this can be any data you want, this can be streaming data, and so on, but I will come back on that later. Then you have your data consumers, people who are consuming your data. This is done through APIs. We offer several APIs for several use cases. So those people are consuming your APIs. And then, of course, next to that, we also built some sort of notification engine that allows people to subscribe to certain data. An example of that is when a customer is expecting a certain container, they can subscribe to that container. If that data then enters the platform, they get notified that there's new data available, and they actually get the data immediately instead of consuming the APIs. So let's first talk about the data ingestion, and the core team there is creating that discoverable metadata that is important for the platform. So let's talk a bit on the types of data. So there's a lot of companies in the harbor, so a lot of types of data. So I'm wondering, by show of hands, who thinks that JSON is the most ingested data format in the platform? One person? Okay. No, so customers are ingesting data into the platform, and who thinks it's JSON format? No one? Who thinks it's who thinks it's streaming data? IoT data, streaming data. Okay, not much. Who thinks it's XML? Couple of raise of hands. Who? Sorry? Yeah, it's coming. Hold on. Who thinks it's TXT, CSV, plain flat files? A lot of people. Who thinks it's EDI? So I probably hear you thinking, EDI? Seriously, what year is this? So EDI is the most ingested data that is in the platform. So there's 80% of the data that's coming in is EDI. And I hear people thinking, yeah, are people still using that? Yeah, there's a lot of companies who are still using that. I've looked it up, and around the 70% of the Fortune 500 is still using EDI in their day-to-day businesses, sending invoices or anything like that. So data ingestion, so when data enters the platform, this can be different types of data. So it's Edifact, X12, TXT, JSON, and so on. So people ingest the data. We keep an audit trail on which data was ingested by who and when. And this can be done over different kinds of protocols. So it's HTTPS, FTP, SMTP even. People want to email their data files for some weird reason. So X400, AS2, everything is supported. So and for that data ingestion, you really need your platform or your ingestion layer to be super flexible. So you need to support messaging. So you need to support data wrangling. So for example, if an EDI file comes in, you don't want to actually store it as EDI, but you want to do some transformation on it. You need your B2B and EDI capabilities that are important. As said, if you're going to do EDI, you need those B2B capabilities. And of course, you need your classic application integration patterns that are used when handling data. And this is where serverless comes into play. So in our data platform, serverless is really the heart of our data ingestion. So we are using Logic Apps Function, Service Bus, and Blob Storage and Azure Search to really allow that flexibility, to allow those different protocols to be supported. So if we take a look at the high-level architecture here, so we have our data providers providing data through Logic Apps. So Logic Apps is really here a platform protocol enabler, and it allows us to bringing the data through several ways. So it supports polling on FTP, it supports AS2, it can host HTTP endpoints. So it's really there as a protocol enabler for our platform. So once the data is entered, we store that data onto Blob. So we have some hierarchy and folders that are which we store the data in different folders by file format, by sender, by receiver, and so on. So once that data is inside Blob, we have an Azure function running on that blob who will add metadata onto that blob file. So we have a function running that knows which file format he's currently reading, applying metadata. For example, if it's a shipment order, we will add the shipper and so on. We know if it's an order, we add the order ID based on the insights of the documents. So, and then we have Azure Search running on top of that, who is basically acting as an indexer on top of that blob storage to allow APIs to quickly query the data inside of blob storage. We tried writing some queries directly on top of blob storage, but that turned out not to be a good idea. So let's quickly run through a small demo. So let me go to the portal. So what we have is to show you. So I'm currently, I have here a logic app running. Let me zoom in this a bit. So this is a simplified version of the logic app. Well, in the real case, we actually have different logic apps. We have decoupled this for optimal use, but this is just a simplified version of the series of logic apps we have running. So what we are doing here is we're exposing an HTTP endpoint. We extract the sender and the receiver for the EDI message. We parse it, and then we basically use out-of-the-box functionality of the logic app's service to decode that edfuct message. So that will basically transform that flat file into an XML, and when it's ready, we store it into blob storage. So next to that, we have Azure Function running on top of that. So give it some time. So, and what we are using here is, for people who are familiar with functions, we are using the blob trigger, and that basically every time a new blob arrives, we get the trigger inside the inside functions, and we do then some extraction of data on it. Again, here this is a simplified version, but what we're doing is we're basically getting values out of the XML we're getting with XPath. We're adding it to the metadata, and then it gets onto the blob storage. So if we go take a look at the blob, as already said, this is Storage Explorer. So if we go into details of it, so I removed all the customer and replaced them with Boost. So it's, I think it's, I see that I made a typo in Mintu. Sorry for that. So what we're doing is we're actually adding all the metadata onto the blob. So we're adding a stay number, the document ID, the message type is there, the sender ID, and so on and so on. On top of that, as already said, we have Azure Search running, and how Azure Search is working, you need to specify a data source. In this case, we've specified our blob, and then you need to apply some indexer. There's an issue over there, but it's okay, I will work with that. So an indexer that is running each couple of minutes, that takes a look at your storage and basically creates an index on top of that. So, and then you can start querying that index. So if you go directly to Search Explorer, who takes some time, let me just reload that. It's taking some time. Let me, okay. So I can here now start searching that index for some, and it really takes some time. So let me, so what it does is it allows you, it basically creates an index on top of that metadata, and it gives you the actual, then the storage path directly to the file that has been indexed. And here you can create different kind of queries. So for example, if I want all the Mintu files it basically comes up like that. I can search on specific document IDs. So I can specify, I can filter on document IDs, search it, and then only this document ID will come up. So, and this service is basically the core that we're using inside our APIs. We're using this service throughout our APIs to get all the data we need from blob storage. So back to the slide deck. Some lessons learned and takeaways when during our data ingestion process. So we had quite some issues with cold start of functions. So some guidance over there is to keep your dependencies small. So how functions work is, and Chris will probably correct me if I'm wrong, how functions work is when your function is called and it gets called the first time, it deploys a package onto a VM, downloads all the necessary dependencies, and then fires up your function. So if you keep the amount of dependencies in your function small enough, it fires up faster. So that was correct, right? Kinda. A good way to avoid a pinger is a good way to avoid cold start is to implement a pinger. So a function instance is kept alive around 15 minutes. So if you then figure out a way to fiddle your function every once in a while, then you can keep your function alive. You can always run a non-consumption plan, but then you will, of course, pay more. So with functions, you can, as your functions are, when your function is live, you can use your static, declare static variables on top of your function, and then you can use that throughout of your function. So, for example, you don't need to create a SQL client every time that your function is called. So logic apps. So it's logic app is there. A good thing and a good way to approach logic apps is to decouple protocol and message processing. So it's better that you build several logic apps, one that enables your protocol, and then bring it to another logic apps who does the message process, and keep in mind that you designed for reuse. So you have to live with some limitation of some Azure services. For example, in our case, the Azure Search Indexer was a limitation we've hit. So the indexer is only running each 5 minutes. That's the minimum amount you have to specify. So by the time data is ingested into the platform and can be made available through the APIs, there's a maximum time window of 5 minutes. So we had to live with that. Our customers had to live with that. But we had some workaround with that with our notification engine. And for serverless is don't forget your outer loop development. So for people who are not familiar with the outer loop development, so you have your code run debug, and it's basically the entire chain. So it's very easy to go into the portal, create a logic app there, or create functions over there, but keep in mind that you really need everything in source control to have that entire chain up and running. So the next part is about data sharing and notification. So it's sharing the data that has been ingested and be notified on events or be notified on certain data that is entering the platform. So there's a couple of data types or data streams that are available in the platform. So we have open data, and open data is basically accessible to everyone. So everyone who has access to the APIs can basically access the data. So then there's linked data. Linked data is, for example, every data or message that has to do with a certain container number you will have access to. A good example there is if you order something online, you get your shipping number. So, and that everything there is basically, you see all the flow of that shipping number as a linked data. And then, of course, there's shared data, which is the least amount of openness. So it's a data supplier who will actually go into the portal and say, okay, this one can see that data, this one can only see that data. So it's basically shutting down most of the openness of the data. So as already said, data providers will provide data into the platform, and then you have data consumers who will consume the data. And then you have ISV and app developers who will write APIs or applications on top of that data, and who will call the Nextport platform or the data platform in name of the data consumers. So inside the portal, we only see actually data provider and data consumer, but the ISVs and app developers are linked with the data consumers. So our data sharing engine, or the data sharing engine, works in a way that data is non-consumable by default. So when the data provider starts transmitting data for the first time, it enters the platform, but it's non-visible for no one. So then the data provider can go into the platform and start adding his sharing rules on top of the data he's providing. And he really can open up data to different entities. So the platform is taking in data, it's attributing all the values in the supply chain. So it's adding, okay, this is a shipper, this was the supplier, this is the forwarder. So, and that way, the data provider can say, okay, I only want to share my data with the data, with the forwarders and so on. Next, you have your event processing. Basically, I have a 5 months old baby, so it always calls me, and I don't call him, but he always calls me, yells through that annoying thingy. So, and this is basically how the event processing works also. So it's not the data consumer who is pulling the platform or pulling the API, but we will call the data consumer when some data is available for him. So again, as it works here, so data provider provides data, and we send the data through the consumers. So we send it through webhooks, through emails, to AS2. The downside of working with different companies is that you even have to support some really old protocols, well, not modern protocols, so you have to support EDI, so even we had to drop files on FTP and so on. So it's really not as simple as just using some webhooks to provide them with data. So as already said, the advantages of this is we don't have to wait that 5-minute window of Azure Search. It's faster. It's more efficient for the data consumer, as he doesn't have to pull everything like that. And the disadvantage is that because we worked with many companies, we had to support some really old protocols. So, and coming to the most important part of this is the API economy. So we're publishing, and people are consuming assets via the marketplace we're providing. So every data that is entering the platform will be consumable through an API. So as you all know, we're living in an API economy. APIs are booming. Everything is an API currently, and we see the uprise of those APIs becoming more and more important. So it allows companies to share services with third parties and really bringing their business to a next level. So the goal of the API layer is to open up the information and the data in a secure way, and it's really there to create a seamless experience for the people who are using it, and it's there for automated data sharing, and of course we have API monetization in place for that platform. So talking about monetization, there's a couple of monetization models you can choose from, and you can choose for free. You can allow the dev being paid. You can go for the freemium tier, the unit-based transaction fees, and so on. So, and choosing one of those models is really difficult. So there's not there's no silver bullet to rule them all. So it's really difficult to have that correct data monetization or monetization plan into place. So how the monetization works at Nextport, we have a bit of best of all, let us say. So depending on the type of API you're consuming, you're paying one fee, you get it for free. The subscription even can be monthly or yearly, and you sometimes even have to pay per transaction, per unique request. If we push data to you, you also get billed. So, and of course we have discount if you really have a big volume. So as you can see, it's a pinch of everything that we have as monetization. So, and to have that all in place, we have Azure API management, who's really the core of the API economy and the core of the API platform we're having. So it's, as already said, it's the main entry point of the platform. People go in there, consume the APIs, the data ingestion is flowing through API management. So it's the main entry point of all the flows that are entering the Nextport platform or a data platform in general. It allows you to build a streamlined approach on security, on monitoring, on logging. So it's basically allows you to streamline everything regarding your APIs. So, and Mike will be happy if I mention this. So PowerShell is our friend. It really is. So PowerShell is helping us a lot to really automate everything regarding API management and API onboarding and so on. So the platform allows automatic API onboarding, external and internal. So Nextport is not only building API themselves, but also allows companies to bring their own APIs into the platform. So, and with that, we have automatic API onboarding, which means we only need a couple of configuration files from the company or from us to allow that API to get hooked into the Nextport platform, into the marketplace. So what happens is, I will show you a demo later. So we check in a Swagger file, some configuration file that gets through our entire CI/CD pipeline. When that API is published, it will be published to Azure API Management and be made available inside the marketplace. And Azure API Management is, of course, there to enforce the price plan. So a couple of things we are doing, or you should do, before opening up an internal API or to open up an internal API. You need to have your security okay. You need your API documentation with Open API. You need your governance okay. And you, of course, the most important thing there is to define some KPIs to measure the success of your API programs. If you put an API out there and no one is consuming that API, it's really useless. And then, as already said, we are really keen on having that automated onboarding in place. So for us, it's important that all the configuration and all the files are there to allow that automated onboarding to be seamless. So with Codit, we started to define some practical API guidelines which are available on GitHub, and we're working there to bringing all these things to have some sort of best practice on building APIs. So it's an open repository, so we're happy to receive your feedback or any remarks. If you don't agree with us, we're happy to talk and we're happy to take in pull requests. So if we go and take a look at the high-level architecture of the API platform and of the API onboarding. So as already said, you have a Swagger file, some configuration file. We'll put that in our repository. We check that in. It gets automatically deployed into API management and made available onto the Nextport platform. Then people can start subscribing to that API. In some cases, it's necessary that that access to that API gets approved by an operator. So if that is approved, or if it's automatic, it gets sent to our backend process, who is running in Service Fabric, who is then updating API management to allow the user to consume that API. He's generating keys and so on, basically creating that entire subscription flow. And then when our backend process is done, we send something back to the platform that will allow the user to start consuming that API. So I will quickly show you a demo. I see that I have 15 minutes left, so I will make it quick. Let's go here. So I want to show you a bit on how that we do automated API onboarding. So let's first go to our API management instance. As you can see, there's currently one API available. It's the Amadeus Travel API, who is widely available. So, and what we will do, we want to onboard a new API. In this case, we want to onboard a new API being the pet store. So let me see. Let's not create a fancy title, no description like we always do. So as already said, there's a couple of files that we need to check in, and this is really how it works in production, in the platform also. There's 3 files that we need to provision. So it's the API definition, who is basically just the Swagger file. Then we need to provide some default policy. So for people who are familiar with API management, you will recognize that. And then we add some metadata that will give you a description, will give you the path, the protocols, the products, who are some fancy GUIDs, and then some other settings. So if I now approve my own pull request, but that's the way how we roll. Complete it, that's the way how we roll. So once this is completed, the build will start. It will build that for me. And once that build is done, it will fire up the release pipeline. So let's give this a couple of seconds, Should be rather quick if there's an agent available, of course. So the build is actually taking all the files and just prepping them in folders. It's just cosmetic stuff. So sorry? Yeah, not here, but we do have some validation if everything is okay. So we run the Swagger against a validation entry. We validate all the configuration, so that is available in the real platform. But for quick sake, I didn't do it here. So the build has been done, and as you can see, a new release has been fired. So, and what that release does is basically running a PowerShell script who will deploy that through my API management layer. So let's give it a go. Maybe let's jump first to the lessons learned here, because I see that time is running out. So, for your internal APIs, make sure that you have a goal defined for them. So make sure that you have KPIs defined, that you're sure that your APIs are used and they have a goal. So make sure that your API security, documentation, and governance okay, and make sure that you maximize out your developer experience. And it's all about automation, automation, automation. It's really key that if you plan to onboard several APIs, that you don't have to do this manually each time. So make sure that you have your automation completely in place. And for your monetization, make sure that there's visibility on the costs, so that that you know that your consumer or your customer knows what he's going to pay in the long run. So let's go quickly back to this one. It's taking some time. Let me go to the portal to see if there's... So let me, in the meanwhile, show you the Nextport platform. So this is the Nextport API market, which allows you to basically... there's a couple of APIs available, which allows you to subscribe to them. So if you go to one of these APIs, you can go there and... I think it's data user. You can basically start subscribing. Of course, you will need access to the platform, but you can easily subscribe to that. So for people who are wanting to try this out, to play with data of the Nextport of the harbor of Antwerp, you can just go there, subscribe, and start building application against data. So, and if you go then to the console, you basically see on what subscriptions you have, and you can go on there. So if we go back to our release pipeline, it's still. Let me just refresh this. Always works. So if we go now to API management, you will see that there's a new API available, and now we can basically start using this API through our platform. So back to the slides. So the road ahead for the platform is basically onboarding more data, onboarding more APIs, and it's really convincing companies and people who are working in the harbor to share their data, because that's always a bit of a tricky part. The ultimate goal, and that will come with implementing AI on top of that, is to start detecting suspicious activity end-to-end to the entire logistics chain. So we will have offshore container tracking. We have suspicious activity detection on the terminal. With IoT data flowing into the platform, we will be able to monitor in transit conditions. So if you have a container that is refrigerated and someone opened it up and you will see a rise in temperature, we will be able to know that. And it's basically end-to-end traceability of the goods, of the data, from the loading until the sign-off at the end warehouse. So, and it's basically all about bringing efficiency into the harbor, allowing everyone to benefit from everyone's data, and really to have that data sharing going on. So, before we jump to the conclusion, does anyone have questions? No. So some takeaways. So regarding data ingestion, make sure that your platform is flexible. So make sure that you can handle different kind of protocols, different types of messages. Make sure that you're flexible enough to handle all these things. So designed for reuse. So split up the things you think you can reuse. A good example there is Logic Apps, that you split up your protocol enablement with your process. And the most important thing is remember your ALM, your CI/CD, even in your serverless scenarios, where it's super easy to go into the portal and start fiddling around, but in the end you will run into issues. Data sharing. There's different types of data, and the thing there is make your data non-consumable by default. Your sharing engine. We made the mistake there to overbuild it from the start, where we should have thought big but should have started simple. So we've had to rework that a bit. So and always take flexibility over complexity. So it's finding the right balance over there. Data monetization. There's no silver bullet solution there. So it's usually a mix of everything, but the most important thing there is be transparent about the end cost for the customer, because honestly, that's the most important thing. API management. Make sure that you have a defined set of rules there before opening up an API. Make sure that your APIs serve a goal, monitor them. And of course, an important thing is think about automation, as it's super important. As already said, data is becoming more and more important, so it's the fuel of our economy of the future. You will see more and more data coming in. If I see the stream of messages and data in a certain WhatsApp group today, you will know that there's a lot of data popping up. So if you don't have questions, now you can reach me through this. Yes, sorry.
How much data you have?
How much? There's about 560,000 files currently inside the platform. Size-wise, it's around between the 3 and 15K a message. So it's really it's a small message. So it's not that big. Any other questions? So it monetizes through the consumption of the APIs. So if you subscribe to certain APIs, you will need to pay a fee, and they monetize that through the fees. Not for the moment. So it's a global, it's a joint community in the port, couple of companies are investing in. It's a startup, so a couple of companies are investing in it. So it's really, as they're starting, it's an investment for everyone. So it's that's currently the status. Yeah. We're currently working on bringing currently more APIs into the platform and trying to basically add more building blocks on top of it. So we're now looking into AI, how we can leverage that to build more on that, to learn from the data we already have and to get those files in there. So it's still work in progress, but the main focus now is building additional APIs on the platform. No, it's a portal built by a partner who is showing all the APIs over there. So it's not API. It pulls in the background. It pulls the information from API management, but it's not the developer portal that has been customized. It's an unwritten. It's a software. I can't remember the name. It's a company who does that as an offering. No, we're using. I lost the name. I will look that up for you. Sorry.